Okay. Are you guys able to see?
No, ma'am.
No. Um, Manahil, are you also not able to see Mahito? Are you also not able to see? Let's see. Gosh, I don't know what's the problem. Is it fine now?
Yes, ma'am.
Okay, cool. So we're gonna start by question 4, and if we have enough time, we'll just jump to question 5. Okay. So basically, here we're gonna be applying our exponential laws that we've done in previous lessons. And the first one that you're seeing here says c squared plus c squared plus c squared. And does anybody want to try? Maybe I do it on my side. Ole, how would you do this one?
Ma'am, what number are we doing?
You're on this one over here. See.
Ma'am, ma'am, can I calculate?
Yes, you can. Manahil, what is the first thing that you're gonna do there when you have a c squared plus c squared plus c squared?
You are going to say C plus 2 times 2 times 2.
You're going to say, can you say that again?
You are going to say um, C C to the power of 2 times 2 times 2.
So you're going to say c to the power of 2 times 2 times 2. Is that what you
Yes.
said? Okay. Um, Thank you for trying, Manahil.
Ma'am,
Uh, yes.
ma'am, ma'am, I think it's going to be 3c to the power 2, ma'am, because of in front of every c, ma'am, there's an imaginary one. So you add that imaginary one, and it gives you 3. Then that c's, they still stay the same as well as the exponents, ma'am.
Yes. So basically, Manahil, this is how you're supposed to do it. So when you are adding the same base, you just add the numbers, okay? When you are adding the same bases with the same exponents, you just add the bases. In this case, we have um, invisible 1 before the letter C, okay? So it's more like it's 1c squared plus 1c squared plus 1c squared. So you're just gonna add those ones together, which is going to be 1, 2, and 3. So that means we're going to be left with what? We're going to be left with 3c squared. Okay. So the only time that you're going to be multiplying the exponents is when you have the brackets, and then the brackets has an exponent, and outside the brackets there's like another exponent. Okay. That is the only time you're going to find yourself multiplying the exponent. Let me show you an example of what I'm talking about. Let's see. So let's say, for example, and here we had c to the power of 2 to the power of 2, like that, okay? So this is the only time you're gonna say c to the power of 2 multiplied by 2. Okay? Do you get it?
Yes.
Perfect. Still, if you have something like this, let's say they say c squared multiplied by c squared, we're still not gonna say c to the power of 2 multiplied by 2 like that, because when we are multiplying the same base, we add the exponents. This is the only time we're gonna be adding the exponents if we are multiplying the same bases. Okay. So in this case, we are adding the same what we are adding the same bases with the same exponents. So that means we're gonna add the number before the whole thing, which is the c squared. So basically, this our c squared that you're seeing here represent a whole letter. We can say it represent a whole thing as this one and as this one. Okay, so you can take this as one. So let's say for example, you had like these were your what is it, your grapes. Let's say you had grapes. One grape is equal to c to the power of 2, and then also this one is equal to c to the power of 2, and then this one is equal to c to the power of 2. So you have one grape, two, three grapes. Okay, so that means you're gonna add 1 plus 1 plus 1, which will give you what? Will give you 3. And we said c squared is the grape, so you have 3 grapes. So this is the grapes, this is the number of grapes. Do you get it?
Yes, ma'am.
Perfect. I'm not sure what's happening to my heat, or I'm not sure if you're able to unmute your mic. In case you're able to, just let me know if you are also okay there on your side. And let's continue. For B, we have 3A minus 2A minus 5A. And for this one, remember I said if you have like same letters with same exponent, you're just gonna add or subtract the numbers, okay? So in this case, we have the same letter, which is what? Which is A, and we have, remember, invisible to the power of 1, which is the same as the letter, just the letter itself. So you're just gonna add the 3, and then you minus the 2 and minus the 5, okay? So it's just gonna be a 3 minus 5 minus 2. And then you're gonna be left with whatever that you find A. Okay, so it's going to be 3A, which is what? 3 minus 2 minus 5, which is minus 4. Is it minus 4? Then your answer is going to be minus 4A. I think it's minus 4 because 3 minus 2 is 1. 1 minus 5 is minus 4. Yes, absolutely. Do we have any question?
Ma'am.
No question. Okay, that's good. Um, let's move to not number, but letter C. We have C that says 3P multiplied by P. 3P multiplied by P. Manahil, wanna hop on that?
3p multiplied by p equals 3p to the power of 2.
Wait, what did you say?
I'm working on C.
Yes.
3p times p equals 3p to the power of 2.
Perfect. So your 3p multiplied by p is the same as 3p to the power of 2, because remember we have invisible 1 here. The 3 is going to multiply the 1, and the p is going to multiply with the p. And I said when you're multiplying the same base, we add the exponent. So it's like 3 multiplied by 1 and p multiplied by p. And remember, I said if we just have a letter, that means there is an invisible to the power of one, invisible exponent one, okay? So this is more like p to the power of 1 multiplied by p to the power of 1. Okay. And when I said when we multiply the same base, we add the exponent, this is what I meant. So it's p1 plus 1, which is equal to p to the power of 2, or p squared. Then the 3 will multiply the 1, and 3 multiplied by 1 is 3, because we know by now that anything multiplied by 1 is that very same thing, okay? So we have 3p to the power of 2, like that, being our final answer. And thank you, Manahil. 3p to the power of 2. Any questions so far? Are we all good? Oh no, sorry guys. Hey, okay. Are we all good? Any question?
No, ma'am.
No question. Okay, that's good. Let's move to the division. So we have 6b divided by 3b. And let's see if my Hebrew is still in here. My oh, okay. I'm not sure what's happening to her or him. Okay, let's do D Ole. So we have 6b divided by 3b. How are we going to answer that?
Ma'am, first we are going to say 6 divided by 3. Ma'am, it's going to give you 2.
Hmm?
So 6 divided by 3 is going to give you 2, right, ma'am?
Mm,
Then
mm.
b b divided by b, ma'am, it's the same as 1, but then that 1 you don't write it, so your answer is going to be 2.
Perfect. So we're gonna start off by dividing the numbers. So we are dividing the numbers. Um, um, yes. So thank you. We are dividing the numbers because there's nothing between the numbers. There's no plus, there's no minus between the whole thing. It's just 6b, okay? So that means there's an invisible multiplication like that dot, okay? That led it to be a 6b, all right? So we're just going to divide the numbers together and the letters together. So we're going to have what? We're going to have 6 divided by 3 being 2, as you have indicated, Ole. And then for b divided by b, we're gonna have 1, okay? And the reason why we are having 1 is because when you are dividing the same base, you less the exponent, okay? So b divided by b, remember I said if it's just a letter, there's an invisible 1, okay? So it's the same as b to the power of 1 divided by b to the power of 1. And I said, remember just now, I said when you are dividing the same base, you less the exponent, okay? So b to the power of 1 minus 1, okay? That's how it's going to be. B to the power of 1 minus 1, like that, because I said this is going to minus this. So this one is going to be minus from here because these are the same bases. B and B are the same. Okay, so b to the power of 1 minus 0. I mean, sorry guys, b to the power of 1 minus 1 is equal to b to the power of 0, because any number minus that very same number is equal to 0, okay? And we know that b to the power of 0 is equal to 1, because anything to the power of 0 is equal to 1. Therefore, we have what? We have 2 and 1. So we have 2 multiplied by 1, which is the same as 2. So that means 6b divided by 3b is equal to 2, like that. Are we all good? Are we all happy?
Yes, ma'am.
Manahil? Mahito?
Yes.
Perfect. Um, perfect. Now let's take a look at E. So E is a bit long, okay? So I'm just gonna wipe this so you can have like a clear view of it. We have 3 multiplied by A plus 4 multiplied by A multiplied by B minus 2 multiplied by A. And let's start with you, Manahil. What is the first step that you're gonna do? What is the first thing that you need to do? What does Botma say?
You a group them.
Hmm? Manahil? I'm still here, Manahil. What are you saying? Okay, I'm not sure what's happening to Manahil. Ule, can you hop on it? What does Botman say?
Ma'am, you brackets first.
Brackets, but we don't have brackets. What do we move to? Do we have
Multi
bracket? Multiplication. Perfect. And what are we going to multiply?
Ma'am, we're going to multiply 3 multiplied by A.
Mm-hmm.
Then we're going to go to 4 multiplied by A, then B minus 2, ma'am.
So you're gonna multiply this, and wait, what did you say?
Ma'am, I said 3 multiplied by A, 4
Perfect.
multiplied by A, B minus 2.
Wait,
No. Negative 2 multiplied by A.
can you say that again for the last time?
3 multiplied by A, 4 multiplied by A, and negative 2 multiplied by A.
So I'm just gonna highlight what you're saying. So you're saying we're going to multiply 3 with A, 4 with A, and minus 2 with A. What happens to this B? Hmm?
Or maybe we can say A multiplied by B.
A multiplied by B.
Yes, ma'am.
Okay, so this is what you're gonna do too. Um, this is what you're gonna do, right? So you're going to say 3 multiplied by A, and then you're going to say plus in brackets 4 multiplied by A multiplied by B. So you see, if this one here has 3 terms that are multiplying each other, which is what? Which is positive 4, A and B. So these ones are going to be multiplied together, all right? So that means we're going to have 3 multiplied by A, which is going to give us 3A, and then we have positive 4 multiplied by A multiplied by B. It's going to give us a positive 4AB, okay? And then we're going to have a minus 2 multiplied by A, which is going to give us a negative 2B. 4a. All right. So at the end, not the end, but almost, uh, at the end, we have a 3a plus 4ab minus 2a. Okay. And by looking at this, we can see that our like terms is 3a and minus 2a. All right. So that means we're going to sum that up, the 3a minus 2a, because we cannot mix it with this one because this one has um uh an acquaintance, this one which is b over here. All right, so we don't need that. All right, so that means we're just gonna add these two together, which is going to be 3a minus 2a, which is going to give us 1a, but we cannot write 1a in maths. We're just gonna say a plus, because the 3 is positive and the 2 is negative. So that means that we're going to have a positive a, minus, sorry, plus 4ab. This is going to be our final answer, or you can present it as 4ab plus a. Okay, however you put it is okay, as long as you have a positive 4a and a positive a. Okay, any question?
No, ma'am.
No question. Hill, are you fine? Manahio, Mahito. Oh, not you. Manahio, are you fine there? Um,
Yes, ma'am.
what was happening?
Ma'am, I couldn't hear you.
Couldn't hear me. But did you
And
understand?
also there's
Hmm?
yes, ma'am.
Did you understand what we were doing here?
Yes.
Okay. Now let's look at F. Let's see. Oh no, why am I trying to stop? Are you guys able to see?
Yes, ma'am.
Yes.
Um, okay, Manahil, let's do F. What are you gonna start with? Let's do F. We have 3 open brackets, x minus y close bracket minus 2 open bracket, 2x minus y close bracket minus 3x.
You are going to start with you're going to write 3x um 3xy.
Manahil, you can continue. I can't hear you anymore.
I think you're going to put the x and the y. So there's an imaginary
What?
one on
Hmm?
the x and the y,
Uh-huh.
and you're going to minus that, and the that gives you 0. So you have 3, and you minus it by 2, and the 2x and the y.
Uh-huh. Okay, thank you, Manahil. Thank you. Let's go to Ule. Ule, do you want to give it a try before I do it? What exactly that she gonna do?
Ma'am, I have no idea.
I have no idea. Perfect. Mahito, do you want to hop on it? Okay. Okay, so guys, when you have something like this, it's not difficult, okay? It's just that you are having a lot in one thing, in one expression. Like you have a lot of things on one expression. So what you need to do is to work with it individually, okay? So let's first look at 3x, sorry, not 3x, but 3 into x minus y. So Manahil, it's not possible for you to minus different values or different letters, okay? You can only minus x with x and y with y, okay? But it doesn't work when you have x and y because x represent a total different something and the y represented a whole a different thing, okay? Maybe let's say for example, if these were your fruits, x was your apple and then the y was your grape. You see, you cannot say gray apple minus grape is equal to zero. Do you get it? So you can only minus things that are the same, which is x and x, y with y, uh, this applies to addition as well, right? So you can only add or subtract things with the same values. Maybe let's say x with x, y with y, y to the power of 2 with y to the power of 2, right? So I'm saying y to the power of 2 cannot minus a y because both of them are different things. They are four different things, okay? Y to the power of 2 represent a whole different value, and then the y as well different, represent a whole different value, which means you cannot add them. You can only multiply them. You can add the exponents when you're multiplying them because they are the same basis. Or you can divide when you're dividing them. You can subtract the exponent because they are the same values. I mean, the same basis, sorry, not the same values, but the same basis. But when it comes to addition and subtractions, it's very strict. Only the ones with same basis and also same exponents. Did you get that? So in this case, we have 3 into x minus y. This applied to you as well, Ole. We have 3 in brackets x minus y. So that means we're gonna multiply whatever that is in the brackets with that 3 that you see over there. Remember, the bottom says you must first start with brackets. We have to make sure that we don't have brackets. So by removing the brackets, we're just going to multiply what's outside the brackets with whatever that is in the brackets. Okay. Guys, I'm gonna bring back my screen now. I'm not sure what happened. I think it's my settings over here. Battery save mode. Uh, okay. Let me try to share my screen again. Share the screen, start, and action. Okay. So as I was saying, we're just gonna multiply whatever that's outside the bracket, which is 3, with everything that's in the brackets, because what's in the brackets cannot be simplified. We're just gonna straight away multiply that 3 with the x and with the negative y. So we're gonna end up having a 3 multiplied by x, which is going to give us 3x, and that very same 3 is going to be multiplying with what? Minus y, not just y, but minus y, okay? So it means we're going to have minus 3y. So this is this in a simplified form, okay? We have 3x minus 3y. And then we're going to go to the next, let me just say a friend here over here. We have what? We have -2. So we're gonna take it with the sign that comes before it. So it's going to be -2. So -2 is going to multiply the 2x, and again it's going to multiply the minus y. Okay. So we're gonna have -2 multiplied by 2x, which will give us -4x, okay? Because it's negative multiplied by the invisible positive over here. Then we're gonna have minus, and again we're gonna have what? We're gonna have a minus 2 multiplied by that negative y, and that is gonna give us a positive 2y. Reason for that is because when you're multiplying a negative with a negative, you get a positive, okay? Are you guys still with me? Am I losing you guys? Or you fine?
No, ma'am.
No. Okay, that's good. Now let's look at the last one over here. The last friend. The last friend doesn't have anybody. Shame. He's lonely. Then that means we're just gonna write him over there as he is because it doesn't need to multiply with anything. Now we have 3x positive 3x minus 3y minus 4x plus 2y minus 3x. You see, we have what we have like terms. Can you guys see that? We have like terms. We have y. We also have the x. Okay, so we can add the x's together and the y's together. Okay, let's start with the x. For x, we have 3x, and we also have a minus 4x, and we also have minus that. Okay, so by just looking at this, guys, I can see I have a positive 3 and a negative 3. That means those two can cancel each other because we know that 3 minus 3 is 0, or minus 3 plus 3 is equal to 0. So that means we're going to have 0x, which is same as 0 because 0 multiplied by anything is 0, okay? And that's it. That means we're going to have this canceling out that. Then we're going to have 4x. Let's see. No, it's actually going to be a minus 4x, okay? And then the 2 is going to add up with that negative 3. Then we're going to end up having minus what? Minus 1y, which is the same as minus y because we can never write 1y, okay? So final answer would be minus 4x minus y, okay? And remember, guys, I told you that if you want to prove if your answer is correct, you may choose two values, one representing your x and then one representing your y. Ne? So you can choose any number from 2 to 5. Ne? So you can say, for example, your x is equal to 2 and your y is equal to 3. Then you're going to go to your very first expression, this one that you're seeing over here, the whole of this. And then when you see x, you substitute with a 2. And then when you see a y, you substitute with your 3. Where you see y, you replace it with 3. Where you see x, you replace it with 2. Okay. And then whatever that you get should be the same as to this one over here. So this one, well, how you're gonna do it? You're just gonna do the very same thing. You're going to replace the x with 2 and the y with 3. So that means if you want to prove this one, you're gonna end up having my 4 minus 4 into 2 minus 3. This should be the same as when you are replacing the values and the x and the y values with a 2 and 3 respectively, and then you should get the same. If you don't get the same, that means your answer is incorrect, okay? So that means maybe you probably did somewhere, I mean, you probably did something wrong along the way as you are calculating. You may need to recalculate or re-simplify or redo it if need be, but if not, if you have like time, enough time, you can. But if not, you move, okay? But guys, do you have any question for me?
No, ma'am.
Manahil, any question for me?
No, ma'am.
Are you guys following? So can you guys see that this is not this is not necessarily um hard to complete. Can you see that? Okay, no problem. Let's do G, letter G. Then for G, we have 14d to the power of 2 minus 7d divided by 7d. Does anybody know what's the first step that we're going to take when we have something like this? Because you can see we have D, we have 7, 7, 14. What is it that comes to your mind when you see something like this? Ole, what comes to your mind when you see something like this?
Ma'am,
Mm-hmm.
ma'am, I think you're going to divide.
You think we're going to divide? How?
Maybe we're going to first we're going to solve the numerator parts first, and then the denominator. Then we're going to write it as the fraction.
Okay, just take me through the steps of how you're going to do it.
First, you say 14d to the power of 2 minus 7d. That
Hmm?
gives you 7d to the power of um, 2.
Okay, Manangil, before you continue, I need to remind you, ne, right? Remember when I said, just today, when I said that if you have a letter to the power of 2 and you also have just a letter with no exponent or with a different exponent, maybe to the power of 3 or to the power of 4 or 5, you cannot add those, all right? But you can either divide when you're required to divide, you can either divide or multiply, all right? But when it comes to addition, it's very strict, okay? We can only add if we have the same base and the same exponents, okay? So in this case, we cannot add the 14 with the 7 because why? Because the 14 has a base of D and an exponent of 2, right? And the 7 has a base of A, an exponent of 1. You see, the other one has exponent of 2, and then the other one has 1. So those two cannot be added together. Do you see that?
Oh, ma'am.
Yes.
Perfect. Just hold on, Olim. So you can only add or subtract if we have the same base and the same exponent. Do you get that?
Yes, ma'am.
Perfect. Perfect, perfect, perfect. And in case you don't understand it, you can ask Nef. Okay. Okay, Ole, you're saying?
Okay, ma'am. Me, in my opinion, ma'am, I was thinking that
Like your opinion.
the,
Okay, continue.
okay, ma'am, 7x and ma'am, the 7D, the 7D under and the 7D on top, ma'am, they
Mm.
cancel each other because of they have the same, like the same base and the same number, ma'am. Then the 14D to the power 2 and the 7D, ma'am. This 14, you have to divide it by 7 so that 14, 14
Mm. But why are we dividing Ole when you said the seven will cancel the seven? Isn't that when you cancel, then you're left with nothing, like with one? Why are we still dividing the 14 with seven if we cancelled? That's just my opinion, eh?
Oh, ma'am, no, ma'am. On ma'am, okay, let's start. Ma'am, on 14D to the power 2 minus 7D, ma'am. You
Mm.
divide that, then it gives you a 2, ma'am, a 2x because of this 2
What, what
minus
do you like so much, eh?
this 2 and the imaginary 1 on the x, they minus each other. So 2 minus 1 is going to give you 1. So for 14D to the power 2 divided by 7D is going to give you 2D. Then after that, ma'am, if you say for if you say 14 if you say 14 if you say 7D and 7D, ma'am, and you move the D from away from each other, ma'am, it's going to give you a 1. So your answer is going to be 2D minus 1.
Perfect, Ule. So your answer is going to be 2D minus 1. Perfect. So this is what you need to do. I'm not sure if you guys are aware of the common factor. So what you need to do is to take out the highest common factor, because by just looking at this whole expression here, we can see that we have what? We have 7 multiples of 7 is 7, 14, right? And that means we can make the highest common factor being 7, and not just 7, we can also see that all the numbers or all the variables has like a letter D. Now we have a D here, and we also have a D to the power of 2 here. So that means our highest common factor can now be what? Can now be 7D, because a 7D can go into this into the 14D squared, and it can also go into the 7D, right? So this is what we're gonna have. Let me try to create space over here. So we're gonna have our 7D uh, being our what? Our highest common factor. Okay, being D. Let's see. Let me try to wipe here again, and then now you're gonna say, okay, what is it that I can multiply the 7D with so that it gives me the 14D squared? It can only be 2D, because when you multiply the 2D with the 7D, you're gonna get what? 2D multiplied by 7D. So the 7 will multiply the 2, which is going to give us 14, and the D and will multiply with the D. And I said when you multiply in the same basis, you add the exponent. So we're going to have 4D, 1 to the power of 1, which is 1 plus 1, which is 2. So you have 14D squared. So in the brackets, we're going to have what? We're going to have a 2D. We're going to have a 2D. And again, you're going to look at the uh, next term here. It says minus 7D. What can you multiply a 7D with to get a negative 7D? It can only be a minus, can only be a minus 1, because you're just changing the signs, okay? Then we're going to divide everything with the 7D, right? So now you see we have 7D here. We also have the 7D here. Remember, I said you can only cancel if there is no a multiplication in between, okay? So that means if I want to cancel the seven, okay, let me just do this. If I want to cancel, I can cancel this with that, and I can also cancel this with that if they were the same, but they are not. And what else? I cannot cancel this with this because there's a minus in between. But in this case, we regard this whole bracket as one thing. It's like the whole thing. It has a negative, but it's not how do I put it? It's it's not an individual thing, right? This is a whole number as it is. Like this one, this is a whole number as it is. So it's like 7D multiplied by the whole of this, okay? So this does not represent two things, but it represents one whole thing, okay? Hence, we are able to cancel in this case. But if we had something like this, which is same as this one over here, we were not able to cancel because there's a minus in between. But if there was brackets in here, we were going to gladly cancel that like this. And let's see. Um, where's that thing of mine? This? No, it's not. Oh, it's this one over here. Yes, 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 yes. Okay, I'm just trying to cancel them. Yes. So basically now see it's easier for us to just cancel the 7 with the 7. Then we are going to be left with 2D minus 1 being our final answer. And remember guys, I told you if you want to prove your answer, if your answer is correct, you can always pick um any number of your choice between 2 and 5 and make it your D. So whatever that you pick as your D, it has to be the same as the one here. So if you choose your D to be a 2, so that means everywhere where you see D, you're gonna replace it with 2, and it must give you the same answer as this one when you are substituting with the 2 here, like this. Is that clear?
Yes, ma'am.
Mm. Okay. And let's look at the last one, which is age. So I think there's gonna be a lesson after this one before they come and join here. We have x to the power of 2 multiplied by 2x to the power of 3 multiplied by 5x to the power of 4. Manahil, remember what I said about the multiplication of the same base? What did I say?
You said that if the base are the same, then you can add the exponents.
Perfect, Manahil. That's perfect. So when you have the same basis, you can add the exponent. So in this case, we're going to start with x to the power of 2 multiplied by x to the 2x to the power of 3 multiplied by 5 to the power of x. Sorry, 5x to the power of 4. How would you answer this, Manahil?
So you say um, x2 plus um, um, the 3 and the 4.
Mm-hmm. And what happened to the
And
still gonna come to it?
you say um, uh, 5 times 2.
5 times 2. Mm-hmm. Then what's gonna be my final answer?
Your final answer is going to be um, 10.
10.
10x to the power of 9.
Oh no. I'm sorry. No, it's not you. It's me. 10x to the power of 9. 9. Perfect. 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 And remember what I said? What did I say about the same base? I mean the subtraction on the same basis.
You
The for the
if
addition.
there,
Mm. What did I say?
if if
What?
there are the same bases and you are dividing, then you can say you can minus the exponents.
Mm. Perfect. You can minus the exponent, and if you have the basis and the same exponent, you can add, and you're required to add. You can add or subtract. Okay, but if they are not the same, you cannot add them. Okay. So with additions and subtractions, it's strict, okay? Unlike when it's just multiplication or the division. All right. So you cool guys. I think I'm just gonna end the lesson here. If you guys don't have any question for me. Any question, Ole? Are you all good?
Ma'am, I'm all good.
Good. Okay. You guys can take screenshot of this last two that we were supposed to do here, and then do them anytime. And if you have any question on those, you can always send me a message or just let me know when we start our next lesson the next time. Okay.
Yes, ma'am.
Okay, guys. I think I'm gonna end the lesson now, and enjoy the rest of your evening and your week at school. Bye, guys.
Bye, ma'am.